Hello students, today we will be discussing electric flux and continuous charge distribution from the electrostatics chapter of your class 12. Okay, so first let us start with electric flux. An electric flux. Okay, what do you mean by electric flux? First let's discuss that. An electric flux is a number of electric field lines that pass normal through a surface. Once again, what is electric flux? It is the number of electric field lines that pass normal through a surface. The number of electric field lines passing normal through a surface is called the electric flux. I'll draw a diagram so that you can understand it more easily. Okay, this is a surface. Now I am drawing many field lines. Okay, these are the field lines. So once again, what is the definition? The number of electric field lines passing normal through a surface. So first we drew a surface and we should also mark the area of the surface. What will be the area of the surface? B. Area of the surface will be D into S. I will tell you everything. Then we will be having 1 minute. Yeah. From here we will be having a vector n cap. And this angle is theta. This angle will be theta. Okay. And here this is ds and ds is the area vector. ds is the area vector. And area vector is acting normal to the surface. Okay, so the number of electric field lines passing normal through a surface is called flux, and flux is a scalar quantity. Flux is a scalar quantity. Then let us see what is the expression for electric flux. Electric flux through the area ds in an electric field E. Electric flux through the area ds. Okay, here the area is ds. Through the area ds in an electric field so the electric flux through the area ds in an electric field E is given by delta phi is equal to E into ds, where ds is the area and that can also be written as E into ds cos theta, because if there is an angle given in the question, then it should be cos theta. Okay, I have redrawn the diagram and ds is the area vector, and here the area vector is acting normal to the surface, that is why it is n cap. Okay, and what are the SI units? The SI units are Newton meter square per coulomb or volt meter, or it is volt meter. So once again, what is an electric flux? The number of electric field lines passing normal through a surface is called as electric flux, and electric flux is a scalar quantity, and the expression or the equation for finding electric flux is delta phi, or phi is equal to E into ds, or if we are given with an angle, then we have to use the formula E ds cos theta. Alright, now the SI unit is Newton meter square per coulomb or volt meter. Now if the flux which we get after finding it using the equation, if the flux which we get is negative, if flux is, first case, negative, when will flux be negative? Flux will be negative if the flux lines are going inside a surface. Flux is negative. 1 minute. Let me remove this if. Okay. Flux is negative if the flux lines are going inside a surface. Flux will be positive if the flux lines are released out of a surface. So flux will be negative if the flux lines are going inside a surface, and if the flux lines are coming out of a surface, or if they are released out of a surface, then the flux will be positive. Going in, flux is negative, coming out, flux is positive. And then another thing which you must note down is, when a closed surface is placed, when a closed surface is placed in an uniform electric field, the net flux through it will be 0. When a closed surface is placed in an uniform electric field, the net flux through it will be 0. So in questions they will give you a closed surface, and if they ask you to find the electric field, and sorry, not the electric field, if they ask you to find the net flux, then since it is a closed surface, the net flux through it will be 0. Okay, when a closed surface is placed in an uniform electric field, the net flux through it will be 0. Then another point is, it is not a closed surface, okay, it is an open surface. If Q net is 0, then flux will be 0. Here Q net is the total charge. Q net is equal to total charge. If it is an open surface, and here the total charge Q is 0, what is Okay, yeah, if the total charge is 0, then flux will also be 0. Q net equals total charge. Okay, just remember this. This is first point. Second point, if the net charge is 0, then the flux will be 0. If there is no charge, then there is no flux. Total flux will also be 0. Then in questions, you will get like this. Sometimes when you get questions, you will get questions based on cubes. Alright, so if the question is flux passing through one phase, find the flux passing through one phase. If you have to find the flux passing through one phase, then it will be 1 by 6th q by epsilon naught. Okay, if you want to find the flux passing through one phase, then the equation to be used is phi equals 1 by 6 q by epsilon naught. And if you are asked to find the flux passing through two opposite phases, flux passing through two opposite phases, flux is equal to 2 by 6th of q by epsilon naught, which is 1 by 3 q by epsilon naught. Flux passing through one phase is 1 by 6th of q by epsilon naught. Flux passing through two opposite phases is equal to 2 by 6th q by epsilon naught, which is 1 by 3 q by epsilon naught. If you get such a question, then you have to use these. Okay. Then another 1 mark question is, when will the electric flux be maximum? When will the electric flux be maximum? Electric flux will be maximum when the angle between the field lines and the area vector is 0. When the angle between area vector and field lines is 0 degree. This is important question. Okay. When will the electric flux be maximum? Electric flux will be maximum when the angle between the area vector and the field lines is 0. So this is all about electric flux, and I have discussed some of the main points related to electric flux. Okay. So once again, let's revise. Electric flux is the number of electric field lines passing normal to the surface, and it is a scalar quantity. Its expression is phi is equal to EDS, or phi is equal to EDS cos theta, where E is the electric field, ds is the area, and cos theta is the angle between the area vector and the field line. SI unit is Newton meter square per coulomb or volt meter. SI unit is Newton meter square per coulomb or volt meter. And if flux is negative, when will flux be negative? Flux is negative if the flux lines are going into a surface. Flux is positive if the flux lines are released out of a surface. And when a closed surface is placed in an uniform electric field, when a closed surface is placed in an uniform electric field, the net flux through it will be 0. There will be no flux if it is a closed surface. Okay, now if the net charge is 0, then the flux will be 0. If there is no charge, if the charge is 0, then the flux will also be 0. Flux passing through one phase. If in question, you usually get it in cube kind of questions. So if the net charge is 0, if the flux passing through, if they have asked to find the flux passing through one phase, use this formula, 1 by 6 q by epsilon naught. Flux passing through two opposite phases, 2 by 6 q by epsilon naught. 6 came because there are 6 phases for a cube. Okay, so one phase we have to find. So 1 out of the 6, 1 by 6 q by epsilon naught. Flux passing through two opposite phases, 2 by 6 q by epsilon naught, which is 1 by 3 q by epsilon naught. Now when will the electric flux be maximum? The electric flux will be maximum when the angle between the area vector and the field lines is 0 degree. Electric flux is equal to maximum when angle between the area vector and the field lines is 0. Okay, so this is everything related to electric flux. Next, let us move on to continuous charge distribution. Okay, continuous charge distribution. There are 3 types of charge distribution. There are 3 types of charge distribution. First one is continuous line charge distribution. Continuous line charge distribution. Then we are having continuous surface charge distribution. We also have continuous volume charge. This is volume charge distribution. Okay, so we have continuous line charge distribution, continuous surface charge distribution, and continuous volume charge distribution. So these are the 3 types of charge distribution. Now let us get to know each one of them. Okay, so the first one, continuous line charge distribution. Just when we see the title continuous line charge distribution, it is understood. Here charges are distributed on a line. Here the charges are distributed on a line. So 3 types of charge distribution. Continuous line charge distribution is the first one, and here the charges are distributed on a line, and therefore since the charges are distributed on a line, it will have linear charge density, right? So the linear charge density lambda is equal to charge by length, which is charge is represented using using Q, length is L. So linear charge density is equal to the charge by length Q by L, and the SI unit is coulomb per meter. Q is C, length is meter. So coulomb per meter is the SI unit. So there are, first one is continuous line charge distribution, and here the charges were distributed on a line, and since these are distributed on a line, it will have linear charge density lambda which is equal to charge per length, which is Q by length, Q by L, and SI unit is coulomb per meter. Second is continuous surface charge distribution. You will just try defining it. It's same way as that of the first one. When it was line charge distribution, charges are distributed on a line. When it is surface charge distribution, here charges are distributed on a surface. And what will a surface have? It will have an area, right? So here charges are distributed on area. Don't write surface. What will a surface have? It will have an area. So charges are distributed on area. And here surface charge density sigma. Okay, sigma, it is represented using sigma is equal to charge by area, Q by A or S, whatever you want, you can represent it. I am using S here. And charge SI unit is coulomb, area is meter square. So the SI unit is coulomb per meter square. SI unit is coulomb per meter square. So here charges are distributed on area. Surface charge density is sigma, charge by area, which is equal to Q by S, which is coulomb per meter square, is the SI unit of continuous surface charge distribution. Now the third one is continuous volume charge distribution. Here charges are distributed. Here the charges are distributed on volume. And volume charge density or volume charge distribution density rho, okay, here it is represented using rho, is equal to charge by volume. Q by volume is V. Charge is coulomb, volume is meter cube. So SI unit is coulomb per meter cube. So these are the three types of continuous charge distribution: continuous line charge distribution, surface charge distribution, and volume charge distribution. Continuous line charge distribution, here charges are distributed on a line. Linear charge density is lambda. For let us make a table. Okay, for line we are using lambda. For line linear charge density we are using lambda. For surface charge density sigma. For volume charge density it is rho. Okay. So and for line charge distribution it is coulomb meter. I will also write the SI unit. Coulomb meter, here coulomb meter square, here it is coulomb meter cube. Coulomb meter cube. Okay. So this is all about continuous charge distribution. So with this we are going to end today's class. we studied electric flux and continuous charge distribution. Hope it was clear to you all. If you have any doubts, please put in your doubts in the comment section. I'll surely reply it for you. Thank you.